This is Chuck, and you must wonder what the hell am I, what the heck am I dressed up for? It's 6 something in the morning, 6:30, Friday morning. We go for a walk every morning, my wife, Howie, and myself, and just getting ready to go. But I thought I'd start off this video. It's 52 in the shop right now, and outside. What's the current temperature in Mountain View?
It's 37 degrees outside.
So 37 degrees outside when we go for our walk. Well, I want to share something with you. As you know, I enjoy to entertain and to educate. And I got educated the other day, and every time I learn something, I really like to share it with you guys out there. A little preface. I'm going to share a couple of links to channels. The RE Cave Shop, which is Dean Crawford. He went to this pick of a machine shop that's closing down. And then another friend, Vince Endter, and I'll put a link to his channel. He purchased the bridge crane and the lathe and a table saw and a few other things out of there. Myself, this cabinet right here, I purchased this tooling cabinet. I purchased the tooling cabinet back in the back, and some other things. And Flea Market Dave, he was there a few weeks ago and purchased quite a bit of stuff also, mostly cabinets. But anyway, as I was digging through all the different items, I came across this guy. And you can see it's got a square shank on the end with balls on it, and this rotates. When it rotates, it spreads the wedges. And then on the front, this is fixed, and then there's a stop on the front. Well, I looked at this and said, I don't know what that is. And the fellow there, Jesse, that's been selling stuff, he goes, it's a spindle stop for a lathe. You basically put it in the spindle, you tighten this back piece, and there's your stop on the front. And you can adjust it in the spindle bore for having the work stop against this front. And what confused me in the beginning was, okay, but why does it have this end on it? Finally realized it after looking at some photos, is that the tool, the drive tool to spin this, locks on the balls. You can push it in, do the tightening. When it's tight, the wrench will come back off. When you go back in to loosen it, you lock back on the balls, you loosen it, and now the balls have enough strength to pull the whole thing back out. Pretty simple, huh? So, Aloris makes this. It's a little over $400. Here's a photograph of it. And how do I know Loris makes it? Well, I went over to my good friend Carl's. I said, hey Carl, you got one of these? And he opens up one of his drawers, which I always marvel when I get him to open up a drawer. There's so many goodies there. And of course he pulled out the Loris version of it. So I said, I got to make this. Well, I got this guy Charlie in my shop. And yeah, you guys may have the same thing. You may have a Jimmy or a Stevie or a Mikey. Well, I'm Chuck, but I turned this job over to Charlie. Go ahead and get this done for me. So Charlie came up with a great idea. He's always good with ideas. So I looked at this and I said, okay, well, I can machine that. It's not that hard. I got to cheat though. After I looked at the Aloris unit, I said, wait a minute, a muffler pipe expander basically opens up and it can create the same thing. It's got the drive screw, it's got everything. So I looked at Horrible Freight. Hey, 20 bucks for an 1.5 unit. 1.5 to 2 inch. Here's a photograph of it. And I said, hey, that's going to be real simple. I'll just take and get me a piece of pipe, fit it in the pipe, and turn it down to the internal bore of my spindle, and then add the extension piece on it. Hey, pretty simple, Charlie, huh? You're a smart guy. So Charlie runs down to Harbor Freight, gets the part, chucks it up in the lathe, goes in to start machining it down. It's I had to expand it, of course, so it sits in the pipe, but I knew I had to get down to under 1.4 inch and 400 thousandths. I hit the go button on the lathe, and I thought, this piece might be hardened. I got carbide. Don't check it, just let's go. Here's the result. Okay, well, you saw that photo. Charlie's a smart guy. So that failed, and of course, yeah, I got my files out and checked it, my hardness files. And it's 60, a little over 60 Rockwell. It's hard. So I thought about it. So I called up Stan Zinkowski, Mr. Heat Treat himself. I said, hey Stan, got this hardened piece here. Explain it. And he goes, well, you got to get it up to about 1700 degrees. He goes, you got an oven that'll do that? I go, yeah, I do. And he goes, then you need to bring it down about 100 degrees for an hour and a half and keep stepping it down each step at 100 degrees till you get down to 1200. Will your oven do that? I says, no. I go, a hot shot would be perfect. Hey, I got a buddy in Texas, Harold Waters, Amateur Redneck Workshop. He just purchased one. So I got a hold of Harold, and actually the parts arrived yesterday at his house for him to anneal the parts, and I still may build that unit. But Charlie doesn't give up at that. Charlie says, let's turn it back to Chuck. What can Chuck do? So Chuck, I'll be right back. Okay, so Chuck re-enters the shop and says, well, hey, I think I can 3D print those parts. Well, there's the piece with the slots. There's the driver. And there's the wedges. Hey, pretty simple. So I'm an amateur at Fusion, and of course, to print this guy, draw it and print it, pretty simple. Draw and print these little wedges. Whoops, they're slippery, the plastic. Pretty simple. Hey, this barrel, pretty simple. How do you put in those 30-degree slots? Well, I tried some more. Finally, I went over and watched James Clow. I remember him doing a video on his laser, not laser, what do you call the damn thing? Plasma cutter, making a holder. And I remember him putting in some slots. And so I looked at that and went, oh, now I get it, yeah. So I managed to do it. Well, there it is, put together. It's got the drive piece out there. I've got a thread here where I can put in some caps. And I've got a unit that expands. Pretty slick. The plastic, so there's really, the PLA I think will work fine, and we're going to play with it and install it in the machine here. There's no stress or pressure on this. Basically, it just needs to secure itself in the spindle bore, and then you're just tapping your part against here. You're not driving the part, you're not slamming the part. This is just going to regulate the part location in the chuck. So, hey, is it a cheat? Can I machine? So, I got to drop back. As I'm trying to draw this slots in this barrel piece, I kind of went, hey, Chuck, Charlie out there, he could have machined this by now. You keep screwing around trying to learn how to draw this. And that's the key, learning how to draw it. It's problem solving. I love problem solving and trying to increase my fusion skills. What I drew here, somebody like James Clow, Randy Richard, about 5 minutes of drawing and they'd be hitting the printer with it. I got some hours. But anyway, so if you notice this guy is dirty, I've started to slide it into the spindle bore, and my spindle bore is full of some swarf and just cutting oil and everything. So I need to get the spindle bore cleaned, and then we'll come back and give it a try. Regarding the parts I sent down to my buddy Harold in Texas, when those come back, I'm probably going to try to machine them just for the shits and giggles of it, and see if I can make Charlie's idea work. I think it's workable. We'll give it a try. You may see a video on it, you may not. A lot of the stuff I do, it's so simple to post on Instagram. I do post a lot on Instagram, and you can always see things there. It goes Instagram and Facebook. All right, we'll take a look at the install on the spindle here. Okay, this is a D13 spindle. So the chuck comes off fairly easy. Basically, using the wrench here, just unloosen the 3 locking pieces. This chuck's light enough that I can handle it. And it comes off that easy. And there's the locking pieces there. And you can see the swarf in there. Let me set this down. And for the fun of it, I'll try to move the camera over and we'll see if we can take a look at the spindle bore. Okay, got a shop towel, and I got acetone. We'll soak that baby up good. Give it a shot down the bore, and give it a little ramrod here. See if we can get it clean. And maybe I got a little too much rag there. A little bit of crap down in there, huh? Wow. Let's give it a turn around. We'll give it another shot. Okay, got it cleaned. Let's get a little air. Okay, give it a little shot of air. And we'll see how the tool fits down here. Well, we can actually try it from up front here first. It should go in either way. Oh, she's tight. Tight on this side. I may have to turn this guy down a little bit. Okay, in the back, it's going in fine. Why is the front so tight? Feels a little rough there. Might be a little corrosion from all the different fluids. Oh, let's see, that's right. forgot, this is a Jarno taper here in the front. I think it's a Jarno 9. Hence, that may not go in the front. So, let me work on how we're going to retrieve it back out of the bore. And I'll bring you right back and we'll give it a test fit. Okay, I have to apologize, it's a little dark here at the back of the lathe, but I'm going to try the tool. What I'm going to use right now is a socket with a magnet in it, which will be my installer and retriever. So let's give it a try. See if I can get out of the way, get you guys in the picture here. So, slides in nice. Let's see. That's the first time I'm sliding it in. Sliding in good. We'll try giving it a tight. Tightened up. And I think you can hear that. It's not moving. Give it a loosen. Give it a loosen. See if my magnet will pull it back out for right now. Think it's coming. Think it's coming. Think it's coming. Ta-da! Hey! Winner, winner, chicken dinner, it works. I've got to address how I'm going to pull it in and out. Right now the magnet's too far back in the socket, and that's why it's not that strong. It's a neodymium magnet, so it's got the strength to pull it. But put it back in. See, loosen it a little bit. Put it back in again. We'll shove it in further. Give it a nice tighten up. Ah, my magnet's stuck with the unit in there. It's tightened up. All right, Charlie, can you get it out now? Oh, Charlie, what'd you do? What'd you do, Charlie? All right, hang on, guys. I'm going to get this guy back out. Okay, I think I got it. The magnet stayed on the end of the bolt, and when I was trying to put the socket in, the magnet was grabbing it and putting it everywhere, so it's still tight. We will give it a loosen. Give it a loosen. It just slid forward. And come on, honey. Come on, baby. Oh, I think it's on its way. Something's coming. Something's coming. Ta-da! Okay. Now the magnet's grabbing good. So, the magnet idea works fairly well. It's nice, and the front guy is nice and tight on the bore for centering it. I just have to make various attachments for the front there, and then as I trip on the mat. And then the only other thing I wanted to discuss was, you can see this one is using a spring to hold the wedges. I don't have a spring here, so I'm using an O-ring right now. I think the O-ring will work fine. I could go with a little wider channel and actually use a bigger O-ring. I think everything here is good. The problem with using an O-ring is, over time, of course, oil and stuff is going to kill the O-ring. Again, this is a unit that I'm not going to be using that often. Here's my little magnet, came out of the socket. So I hope you enjoyed this, guys. I'm going to play with this a little bit more, but I think it's it's got its merit. I'll just have to work on a different attachment, or whether I stick with a magnet in a socket. I'll work that out. May see a future video on this. Anyway, hey, let's close this out. Thanks for stopping by the channel. I really appreciate it. I hope you enjoyed this. And the 3D printer, as you can see, I'm having quite a bit of fun with it. It does produce items. And really, the whole idea with this was also a prototype. Not knowing all the dimensions that I would need for the Clausing, I mean not the Clausing, but the Monarch, printing in a prototype is much quicker than making mistakes with metal. All right, guys, thanks a lot. You can please like, share the video, and comments are always welcome. And hey, I'm up here. All right, take care.